All right, everybody. So I was a little bothered by that whole divergent transitions thing. So I decided, well, let's see what we can do to kind of fix this. So what I did was, if you remember, we got these divergent transitions. Let me pull this up, and it's oops, wrong one. There we go. So this was our original stand that we were doing, and we're using a uniform distribution. And I thought, probably what's happening is the model is getting stuck with these uniform distributions, trying to figure out where exactly the mu and sigma are, which happens if you don't have a very good um, prior. So I thought, well, okay, let's try figuring this out. Let's change things up just a bit and see where we get to. So what I did was I just made them normal distributions, so normal priors. So this is a slightly more informative. It's not a completely, and I should probably reflect that here. It's not a completely flat prior. It's a slightly more informative prior. And what I mean by that is I'm actually using some information that I have available to me. So for instance, I know that based on, the observed treated values for ALT are coming out squarely within the normal range for ALT. So more than likely, it's going to be a situation where the population distribution is probably also going to be within the normal range, because it would be hard to believe that I could do 3 random draws if this population had a mean of 100 and get these 3 values that are very tight. So what that tells me is that more than likely we are actually dealing with normal ALT values. So I can use priors that are slightly more within the normal range. Um, I'm not using, I still have some pretty good spread here. I got a standard deviation of 10 in both cases. What's happening in my head anyway is I want to make sure that I'm being faithful to what the data are suggesting. Keyword here, suggesting, and the data are suggesting that the treatment is still within the normal range. So I felt pretty comfortable doing, a prior like this. And so that's what I did. I changed the prior, and then you go and you rerun it. And here it is reran down here at the bottom. And you can see we got rid of the divergent transitions. Our mu is still solid, 27.5. Our y tilde is solid, 27.5. We still have, quite a spread, right, with respect to the y tilde, so the predicted values. Still has quite a spread. If we go up here, we can see this, 13 to 40, 27.3 is the mean. Here we were 13 to 42. So did it really change anything with respect to y tilde? No, it didn't. This kind of confirms my suspicion when I was looking at the pairs plot, which was, it looks like the model's just kind of getting stuck in weird places. And so divergent transitions technically means that the model isn't able to explore the space as effectively as one might want it to explore. It might be getting stuck in certain areas. In this case, it doesn't look like it was getting stuck, but you can see overall we still ended up with decent, decent estimates here. So I could have stayed with the uninformative priors, but it bothers me occasionally when I see that. So I just wanted to make this right. And like I said, the easiest way to make this right is to reparameterize the model. And in this particular case, we're just going to use better priors. And as a result of using better priors, we get better results. So it's not surprising. That's kind of how this works. But I just wanted to make sure that you all could see, when you're running into divergent transitions, how do I get out of this problem? What do I do? Well, one of the easiest things to do, like I said, is to reparameterize the model. And the easiest thing for me to do was say, well, that prior probably wasn't the best prior in the world, so we're going to try something that's a little bit more reasonable. And as long as you have a good justification for what you're doing, you're generally going to be okay. And like I said before, having these divergent transitions isn't a complete deal breaker. Um, it just we have to be very careful about how we are interpreting things when we see that. So anyway, that's the solution to getting rid of the divergent transitions in a way that is quite reasonable, and you can see that it doesn't change our interpretation any. The treated is still clearly within the normal range, so I feel pretty comfortable with that. Anyway, uh, thanks for watching this video. The next one is going to go into the more than two group comparison, so I hope you learned something from that one next, and I'll see you on the next video. Thanks.